Okay, so let's start. Hi everyone, welcome to my talk about adventures in 3D cartography. You really don't want to go on an adventure with somebody you don't know, so I'm going to introduce myself, especially because I'm a bit of an intruder here in the CityEngine User Meeting. I'm working on the JavaScript API on the 3D side with the Zurich team here, with the Esri R&D team here in Zurich. My name is Raluca. I originally come from Romania, but I studied cartography in Germany, and then somehow I landed up in Switzerland. Now you'll be saying, hey, I signed up for a CityEngine user meeting. Why is she talking about JavaScript? Well, JavaScript is everywhere nowadays. So the idea is Esri has this thing called the platform, and it might be interesting for you. I mean, I guess many of you have already used the scene viewer. Can you raise up your hand? How many? Oh, okay. Now I'm... So, because I was like, nobody was raising hand. I was like, okay, they have no clue what I'm talking about. So your workflow is probably you use CityEngine, you publish your scene layer, you export a scene layer package, you publish it to online, and then you visualize it maybe in the scene viewer or with the story maps or with some custom web app builder. And you probably already know them by how many of you raised their hands. But this is what we call a general purpose app, but you might want something different, something custom. You might want to have that nice special dashboard that no app out there has. So this is what I'm going to be talking about. So in my work, I usually do like documentation and samples and testing for the API. But sometimes I get to do like a bit more like more complex apps, and this is what I'm going to be talking to you today. You already exported your scene layers from CityEngine, and you want to build this app. And this is just a prototype what I was working on. It's called the Manhattan Skyscraper Explorer, and this talk is about why did I want to build this and what were the problems that I had, or like adventures, let's call them this way, and what did we do in the API to come over these problems. So the prototype was about learning about famous buildings in Manhattan. I wanted to see where they are and what they're used for, what did they look like, and I was also interested in like patterns on the island. Where are the old buildings? Where are the new ones? And also in like Manhattan is famous for the skyscrapers. So where are the tallest ones? This was fairly easy, like for me to get the data. I didn't use CityEngine, I used Pro. I took the data from the Open Data Portal of New York. They have tons of data there. And to figure out if the building was actually famous, I was like, okay, if it's famous, then it must be on Wikipedia. That was like my criteria. So I took the name from the data and I plugged it into the Wikipedia API, and from there I got like more information about the building. This is how it looks like in the app. You can see I marked the buildings with this info sign, and then the user would know that he can click on a building and he would get like some information and some images from the Flickr API. So he would also know what do they look like in reality. And this looks all nice, but if I told you that actually when I loaded the points, it would look like this, and I would be like that little guy there, and it's like, where are my points? Because what I did actually was the points came from the centroid of the footprint, so that's how I actually calculated them, and what I wanted was to display them on top of the building. So then I went to Simon and I was, Simon is the developer working on the scene layers. Can you do something to make those points go on top of the building, even if they don't have set values? And Simon came up with the idea, well, let's use an elevation mode called relative to scene. And what this elevation mode does, so you can imagine the buildings are the yellow ones, the ground is the green one. And basically what we do is, for each point, we look at the what is under it. So if it's a scene layer, then we would calculate what's the elevation of that scene layer at that point, and then we would assign that elevation to the point. And basically, by using this relative to scene, your points don't have to have set values, because I tried to put set values actually on them, but they never really match with the set value from the attributes. They didn't really match with the elevation of the building, especially if the building has some interesting shape. So with this mode, you are always guaranteed that your points will be on top of the building. And then there was another thing about this. So for example, if you look here or here, you don't really know what is that, where is the point? Like, what is it pointing to which building? So then I went to Esri, another developer in our team. And we came up with this idea, let's make these, we called them leader lines before, but then we found out that this was also a concept in Pro, and they called them call-out lines. So we decided to, every point we would set or give it a vertical offset, and then we would connect it to the initial point. So this is the initial position, and we would connect it with a line. And like this, you can see it's much clearer to which building the point is pointing to. And then comes the depth perception. So when you look at the buildings, like when you look in the distance, you tilt a little bit. These are all billboarded points, so they're in screen space. So they basically all have the same size. And this is good sometimes, but in my case, for this application, I really wanted the user to actually know that those points are like further away. And what we then did was to come up with this layer mode where you could enable the screen space size, and we would automatically calculate it for you. So basically, the user just has to set this to true, and then we would calculate the points that are further away from the camera. They would be smaller, and the one closer to the camera would be the size that I gave the points. So this is about the points. Now let's take a look at the buildings. In 3D, it's generally a problem that sometimes, because of the shading, you kind of have troubles recognizing the shape of the building. And this is not a problem just in our API. So the gray images, they're from CEUM, and it's a general 3D problem. So then we thought, okay, what can we do about this? And then we thought, what if we would render the edges? And with edge rendering, then you can actually see that even in, like, this would be, let's say, the worst angle I could look at this building from. Even there, you still kind of get the feeling of how the building looks like. And then you get all the details that you otherwise wouldn't see. My other question was, how can I recognize patterns on the island, like where are the old buildings, where are the new ones? And the answer is, of course, color. So I classified my data based on construction year, and I gave a color to each period. And this is how it looks like. I think it's pretty good. I mean, you can really tell that, for example, this area here has older buildings, and then those buildings there are newer. But then you get to an angle like this, where you're a bit like, okay, can you tell me like to which buildings this green here corresponds? And of course you could tell, and you would then start tilting a bit and rotating, and you would figure it out, but it's still not the best. So the cartographer in me said, guys, let's get rid of the shading. And then I went to Adrian, another developer, and he was like, okay, I can show you how to tweak the lighting, but are you sure you want to get to something like this? And then I was like, okay, you're right, that doesn't really look good. But then I was like, but then we have edge rendering. So then I applied the edge rendering, and in the end, I'm not sure. I mean, this is debatable whether shading really is needed here or not, or maybe we could tweak it some more. That's not like the difference between the different faces of the building is not so big. But this is what I somehow got to, and I like it. I have to say that this is not a feature in the API. It's just me playing around with it, and maybe it will come in future releases, but we'll have to see how exactly we will expose this. And now we get to the trickiest question: which are the tallest skyscrapers? And here, using only 3D, like only my 3D view of the city, it can be quite hard. I mean, of course, we have the measurement tool, but I didn't want to give an extra tool to the user and be like, okay, you have to click here and start measuring now. So if you would maybe tilt the scene a little bit and look at it so that the camera somehow looks horizontally, like to the ground, then you could see that the Empire State Building seems to be the tallest. You would get to like this kind of skyline. But what I thought, also because I really like this D3 library, is like I'm going to combine it with a 2D graphic. And I created a 2D scatter chart where each point here is a building, but I only show the tallest buildings. Because if I load more than 2,000 points in SVG, Firefox is going to crash. So then I was interested in the skyscrapers anyway. It's not interesting to see that, I don't know, 50,000 buildings are like very, very short. So I added my buildings as points. And the important thing here, I guess, is I heard this idea also before, always connected to the map so that the users kind of get a feeling of what's going on, like what is this graph and how does it relate to my 3D view. So if you decide to use them in combination, I found that this connection between the two is really, really good. So what I did, like when you hover over a building, then it would, if it's here, if it's a tall one, then it will also be shown in the timeline. And now I'm going to make a fool of myself and make a live demo. Well, I hope it's going to work. So you can access the app at this link. I'm going to show it to you on my localhost because I also have this lighting, tweaked lighting. I increased the ambient light so that you can actually see what I was talking about with the colors. So this is Manhattan, and for example, this building, the moment I hover over it, then it also, you get the information here. Or if I go over it here, then you see it in the map. And then the moment I click on it, it takes a while, and then you get some information from Wikipedia and some images. And then you can actually see that Empire State Building is not the tallest one. It's actually Tower 1, World Trade Center. And then it would be this 432 Park Avenue. I didn't know about this one, actually. Oh, that's a nice picture. Anyway, so the other thing I showed you was this annotated building where you can actually see the buildings that have more information. And then you can go and click on it. And you would get more info about it. And another feature for the time periods is that you can also turn this on and off, and then you would, for example, have an overview of where are the buildings that are the newest. Yeah, so a short demo. Okay, so thank you for your attention. I'm actually like Christian on the conceptual, colorful, nice images side, but I was too shy to raise my hand. If you have any questions. Yeah.
Really amazing work.
Oh, yes, thank you.
I wanted to, okay, a lot of small questions, but what's the base that you're using? Is it Mapbox or is it
The base with the
tiles?
Oh no, it's actually an Esri base map. So we have all these base maps that we provide for free, and this is the gray one, I think.
Okay. Is there any future for using vector tiles?
Oh, we're already using them. I have to give a warning here. In 3D, it doesn't look so good because we rasterized them. But in 2D, like, you can go wild with them, and there are also some really nice ones that are already available out there. Just you can grab them and use them. Very creative ones.
And the analytics that you've produced, well, the graph.
Yes.
So you've developed that.
That's not yeah, exactly. So that's the idea. When you want to create a map like this, you can basically just add any other library you'd like, and I personally like D3 very much, so I use D3 for the timeline. But that would be like, you can make this nice mashup of things, like you saw something there and something else somewhere else, and then you just can combine them, and I think it's really powerful.
Oh, very nice. Thank you.
Yeah.
So maybe, so yeah, it's actually a product, or the RTS API for JavaScript. So you actually can, if you Google that, you can start there. There are many samples.
Java API.
Which Raluca wrote many samples. Pretty cool one.
So this would be the one, like for the 3D web scene. That's what I use to actually create it. So for example, one again with these point styles, this is a sample that I worked on, and it uses the JavaScript API.
So let me just make a point. Are you a programmer? Not really. So there's also stuff where you don't need to code.
Yeah. So if you want to be on the non-coding side, you would go for the scene viewer, story maps, web app builder, and you can also customize quite a lot there too. Like there's a lot of templates that you can use and just drag and drop and create your own web app.
Sorry. What type of license do you need for this?
Oh, you can just, it's for everything is for free, and I expose my app under MIT, so like you can just go take it and play around with it. So you had a question.
Yeah. How you said the idea behind this is basically to just start from scratch if you want to have some sort of, or if you don't want to use a template. So if, let's say, somebody that has a little bit of JavaScript experience, how long would it take you to create everything, all the code you have been implementing in the last example with the maps? How long would it take you to recreate the code structure to replicate this from scratch?
Oh, that's a hard question. So I can tell you it took me, how long, Pascal? 3 months of working every Thursday. And I'm not I'm like, well, as you say, I know a bit of JavaScript and I tweak things and I put them together, so I'm not a developer.
I think if you would have the final design, I think there we had lots of design iterations. That takes you almost more time than the actual coding. That's
Yeah.
I think if you would have given this at the very beginning, if you would have that at the beginning, then just give it to Raluca, then I guess you would have made it in 1 week.
Of non-stop work?
Mm-hmm.
Like 24 hours a day?
How many hours a day?
But it's hard to say. I guess like JavaScript is the language to get started with because it's like the easiest to tweak and you'll immediately see the result and yeah.
The Wikipedia stuff, is that coming in live from Wikipedia?
Yes. So that's why the weird picture with, what was that, a woman saying? No, I don't know. There was some. Sorry, actually, the pictures come from Flickr API, and that's live. And the Wikipedia, what I did was, I actually added. So I used the Python API to actually figure out if the buildings can be found on Wikipedia, and then I put an attribute with 0 or 1, and 1 meant it has a web page there, and 0 it means it doesn't. And then what I do in the app is I check, does it have the attribute 1? And if yes, then I make the request to Wikipedia.
So
That's
then
how
you go
it
into
works.
the information box on when you click the building.
Yes, exactly. Because otherwise I would have to, like, I wouldn't know. It would be impossible to make the request here for all the buildings. So I wanted to be on the safe side and just know, does it have or not. That's how I generated the points too. Cool, thank you.